How's it going? Learning goal number 2, here we go. Learning goal number 2, identifying properties and counterexamples. First things first, let me identify the properties for you. A property is a rule that is always true. So properties in math are things that we always know to be true, and we just learn them and use them as expected. For example, the commutative property. In the commutative property, we basically focus on reordering of terms. For example, in addition, A plus B is the same thing as B plus A, and in multiplication, A times B is the same thing as B times A. Again, this is the commutative property. Also, we can think of it as a reorder property. All right, this sort of quit on me, and I don't know how, but the rest of that word was reorder. And as soon as I get this fixed, we'll look at the associative property. So the associative property. Now, before you get all worked up there about the commutative property, let me re-show that to you again right now so you can copy it. If you need to pause the video then. Okay, back to the associative property. So the associative property is known as the regrouping property. So if you look here in addition, we have A plus B plus C, where B and C are grouped together first in addition. So we do that in order of operations, and then we would add A to it. That's the same thing as adding A and B first by grouping, and then adding C second. That's the associative property of addition. Now the associative property of multiplication is the same concept. Multiply B and C first, and then multiply by A. That's the same exact thing as taking A times B and then multiplying it by C. That's the associative property of regrouping. I would pause the video right now and take a second to copy that down before I give you the distributive property here in a second. Okay, here comes the distributive property right now. All right, the distributive property. Here in parentheses, we have addition happening. And on the outside, we have an A that is multiplying by B plus C. Well, you could actually distribute that through, and AB plus AC would be the same thing you have here. That property also applies to subtraction. So A times B minus C, you could also distribute the A through to get AB minus AC. That is the distributive property. Make sure you have that before we move on. All right, and next we have the identity property. Now the identity property applies to addition and multiplication, but in different ways. Basically, the identity property says this. In addition, if you take A and add it to 0, you will get A again. That's the additive identity. Basically saying if you add 0 to anything, you will get that same thing in return. Now multiplication, if you take A times 1, you get A again. And that's the multiplication identity. If you take anything and multiply it by 1, you will get that same thing in return. Take a second right now and make sure you have the identity property copied down. Okay, moving on. So let's review real quick before we finish up properties. We covered the following properties. We covered the commutative property, which, if you recall, the commutative property relates to reordering of things. For example, if I take 2 plus 3, I get 5. If I do the same thing and take 3 plus 2, I also get 5. That's the commutative property applied to addition. Let's use it with multiplication. If I take 4 times 2, I get 8. And if I take 2 times 4, I also get 8. The commutative property applies to the fact that we can reorder terms in addition or multiplication and get the same answer. It does not apply to subtraction or division. Associative property. The associative property refers to regrouping of items. For example, if I am doing addition, if I have 1 plus 2 plus 3 in parentheses, well, 2 plus 3 is 5, and then you add 5 to 1 to get 6. Now, if you just regroup the parentheses to have 1 plus 2 plus 3, well, 1 plus 2 is 3, plus again is also 6. You can regroup using parentheses addition. That is the associative property of addition. Now with multiplication, if I had 2 times 1 times 3, 1 times 3 is 3, then you multiply that by 2 and you get 6. Well, if I have 2 times 1 times 3, 2 times 1 is 2, 2 times 3 is 6 also. So the associative property applies to addition and multiplication. All right, let's look at the distributive property one more time. We have 2 outside the parentheses, and then we're multiplying that by 1 plus 4. Okay, well, 1 plus 4 is 5 times 2 is 10. Now if we actually distribute that through, 2 times 1 is 2, and 2 times 4 is 8. And if we add 2 and 8, we will also get 10. That's the distributive property of addition. Now that also applies to subtraction. 3 times 5 minus 2. Okay, 5 minus 2 is 3, and then 3 times 3 is 9. Well, if I distribute, 3 times 5 is 15. 3 times negative 2 is negative 6. 15 minus 6 is 9. So that's the distributive property that applies to addition and subtraction. Now finally, let's talk about the identity properties. So if we are talking about addition, and we take the number 3 and we add 0 to it, we get 3 in return. That is the addition property. When you add 0 to any number, it does not change the value of that number. With the identity property of multiplication, if I take 3, for example, and multiply it by 1, 3 times 1 will give you 3. If I take any number and multiply it by 1, I will get the same thing in return. These are our properties. Before we move forward, please make sure you understand them: commutative, associative, distributive, and the identity property. Now, as we talk about our properties and about certain statements in mathematics, we come into this idea of counterexamples. A counterexample is an example that shows a statement is false. Again, an example that shows a statement is false. For example, here we go. State whether the following conjecture is true or false. When they say conjecture, just referring to a mathematical statement of some sort or a statement in general, making a conjecture about something. So we want to state whether the conjecture is true or false. If false, provide a counterexample. Okay, so for example, division of whole numbers is commutative. Okay, the commutative property refers to the reordering of things. Now, I know the commutative property only applies to addition and multiplication, so I know that this has to be false. There may be a few occasions where it may be true, like 1 divided by 1 is the same thing as 1 divided by 1. Yeah, that's different. But let's take an example that will provide us with a counterexample. Let's say 4 divided by 2, is that equal to 2 divided by 4? Well, 4 divided by 2, that's 2. 4 divided by 2 is 2. 2 divided by 4, on the other hand, that's 2 over 4, which is the same thing as 1/2. And those two things are not equal. So therefore, that's false. And this provides as a counterexample for this statement. That is a counterexample as it is shown. A counterexample, one more time, is an example that shows a statement is false. Take a second right now and make sure you have this all copied down before we move forward. So today we talked about properties, all 4 types of properties and how they apply to addition and multiplication, most likely. And also we talked about counterexamples. Now I'm going to give you a few problems after watching this video to try on your own. If you had any trouble with this video, you can always rewatch it. So do so if you need to, and try to answer these 3 questions the best you can. Here you go.